CNT120, Chapter 4, we are now on to Ethernet. Now, Ethernet, as it is, really defines kind of these bottom two layers. And Ethernet, it is a layer 2 standard, but kind of defines it as both layers. It is flexible, capable of running multiple media, good throughput, good cost, and most networks today use Ethernet. So a lot of people use terms like, well, Ethernet cord, Ethernet this, Ethernet that, because most networks use Ethernet. It was not always that case. If you remember back in Chapter 1, initially, each major company was developing their own computer, their own way, their own networking equipment, their own protocols, and things were all very proprietary. Now most everybody uses Ethernet, most everybody uses TCP/IP. So we've kind of come to, that's kind of the general consensus that most networks, most systems are using. The data link layer of the OSI model can actually be broken into two pieces, two sublayers. There is the MAC sublayer and the logical link control sublayer, the LLC and the MAC sublayer. The MAC sublayer here, this is where your MAC address comes from. This is the part that most people think of as your layer 2, your data link layer. Your LLC, logical link control, this is the part that's handling the multiplexing, flow control, error control kind of thing. That's kind of the functional piece. That's kind of the functional piece up there of those functions. So if I look at, this is a picture I found on my own here. Here's your physical layer. Here's your data link layer. Physical layer, we think of a lot of cabling, and that's what a lot of these standards over here are all about. Different types of Ethernet cabling, gigabit cabling, etc. As I move up here, these standards also specify this part of the data link layer. This part of the data link layer. If you think of, my NIC up here at layer 2, part of my NIC has to be the cabling or type of cable that's being plugged into it. That's your media access. How am I accessing the media? The upper part of the data link layer is the multiplexing, flow control, error control kind of thing. That's the part that Ethernet in and of itself, that name, that is a specification of how that gets done for this type of network. So with Ethernet, we have an Ethernet frame. We send our data. We actually have the Ethernet header. These fields are the Ethernet header, the actual upper layer data, which might be an IP packet or something, and then there's a trailer. This is the only time we have a trailer. This is your frame check sequence. That's basically your error check on the end. And you'll notice these fields out here I did not put as part of the Ethernet frame. They serve a purpose of synchronizing and waking up the receiver, if you will. That's how I like to think of it, waking up the receiver. So as I look at my header fields, here are the main ones I see for the header. Here's the data, and then here is the trailer, the frame check sequence. These two fields up here at the top, the preamble and start a frame delimiter, the preamble is really there to start synchronizing the receiver's clock. If you think about a NIC sitting on a network, all of a sudden there's like ones and zeros like bonking it right in the nose. Well, it's like, okay, what do I do with this? So the preamble is just that. It's 7 bytes of essentially 1010101010 to say, hey, wake up. We have real data coming any second now. So the receiver's like, okay, hold on, let me start. Okay, all right, I'm 101010. Okay, I got it. The starter frame delimiter is literally a series of, 101011. It's like, okay, dude, we're done with the synchronizing. We're now on to PAM, the real data that we're trying to send. Destination address, source address, etc. So these two fields are there for really setting it up, and then the real data comes in. That's why they're not included as part of the header, and that's why I didn't include them out here either. They're really there to get it all set up for the receiver to receive this data. So if I capture any Ethernet network, I won't see those. I will not see those fields, if you will. Here is a Wireshark of Ethernet. Here's a packet capture of Ethernet. And like I just said, here's the destination address, source address type field. And that's it. That's pretty much it. Okay. So with Ethernet, we do have kind of like minimums and maximums on our frame size. The header and the trailer make up the 18-byte frame, the Ethernet frame, and then the data goes inside. The data itself may be anywhere from 46 bytes to 1500 bytes. So the minimum would be this 46 bytes plus the 18-byte frame up there, giving us a 46 byte Ethernet frame, the whole way up to 18. That's our maximum Ethernet frame size. MTU, maximum transmission unit, keep that in the back of your brain. Some networks have an MTU, meaning this is as big as a chunk of data that I can process. Anything above that, it would need to be broken into pieces to send it across. Kind of like, I'm not going to put a house on the back of a trailer and drive it down the road. It's not going to fit under bridges or probably go around corners. But if I take my house and maybe break it into pieces, I might be able to ship the pieces and then reassemble it. It's kind of a weird thought, but it gets you thinking that way. If I break it into pieces, I could send it. There is exceptions to Ethernet frame. If I deal with VLANs, I can add a 4-byte frame in here for a VLAN tag. And I'm going to show you an example of that in a minute. VLAN tag, think of that as a way to identify what VLAN this frame of data is coming from. Think of it almost like a luggage tag. Where's this coming from, or where's this going to? And that gets temporarily put on, and once it gets to the destination, it gets torn off. VLANs are virtual LANs. They're a way to take an existing LAN and break it into a couple logical pieces. And I might do a VLAN for my wireless users to keep them separate from the employees in the company, or the wireless users from the IP phones in my company. That's labs we do in our CNT125 class, where we do some VLANs and start separating our users into different groups. We can also have in some networks jumbo frames. This is a proprietary version of Ethernet, allowing basically a larger amount of data to be sent through per time, almost like a larger truck or a longer railroad train or longer railroad car. I can send more stuff with that larger truck or trailer, if you will. So let's take a look at our Ethernet frame. So I'll go out here to my previous Wireshark. Let's get rid of the filter up there, and let's grab a chunk of data from our network. Let's just grab here. Here's a piece of application data. This is probably one of the web page pieces I loaded because I see transport layer security. This is HTTP over TLS, so that's my HTTPS. Well, let's look at the Ethernet header. Here's my Ethernet header. The destination was this device. The source was this device. And here's the type field. There is the only header fields I see. Destination MAC address, source MAC address, and type field IP. And that should look very much like what we were back here. The destination address, source address, type field, and that's it. That's it. That's all we got. Okay. I won't see the starter frame delimiter, etc., etc. So that is our Ethernet frame, our Ethernet header, and my Ethernet header fields. Very basic. But remember, in the big picture now, we also have IP in there, we also have TCP in there, all adding their piece to this so that upper layer devices can read that and get it to the right, right device or the right port or the right process, if you will. I'm going to jump over to, I have a packet tracer file here. Oops. I have a packet tracer file here. Here's a packet tracer file. This is actually a VLAN network that 125 students do. We actually have this switch here and this switch here. And on this switch, if I have the pointer over, if I look down the left are all the ports. Down the, oops, get back here. The third column in, you'll see VLAN. VLAN 10, VLAN 20, VLAN 30. Yes, these two switches have VLANs configured on them. And then this link between them is called a trunk. This link between them is sharing that VLAN data between the switches. So we might have a first floor switch and a second floor switch, or, this building switch and that building switch. So the traffic moving from this switch to this one has to get tagged so it knows what VLAN it belongs to. So I'm going to take and be sneaky for a minute. I'm going to put a sniffer in here, and I'm going to move this cable to the sniffer, and then I'm going to move this cable, or take this cable and go back to this switch. And now any traffic moving through here will be able to see. So I'm not going to go into my sniffer, and let's get rid of all these filters. I don't want all of those. I want to come in here and I just want to see, I'm going to do ICMP because I'm just going to do a simple ping across and then look at that ping traffic. So I'm going to, from this PC here, ping this PC here. Now this PC is plugged into a VLAN 10 port here, and this PC is plugged into a VLAN 10 port here. So they should be able to communicate with each other across this link, so from this part of the building to this part of the building. So this guy, what IP does he have? Let's go here. He has 1204, and I'm just going to copy that so I don't have to try to remember it. And I'm going to go over here, and I'm going to do a ping, and I'm going to paste that address in. And I should have some data moving across this link from this PC to this PC here. So now I'm going to open up my sniffer and look at that traffic. There's my ICMP packets. Well, let's look in here. And I'm going to see, well, this in Wireshark, it kind of spoils you. It shows you the preamble and also shows you the starter frame delimiter. But here's my destination address, here's my source address, and now we have some fields added in here we did not have before. And here's my type field and my data. So preamble, starter frame delimiter, packet tracers being kind and showing you those. Destination MAC address, source MAC address, and then these are the two fields added for my VLAN tag. And in here, if I look real closely at this one, I have, let me see if I can make this a little wider. You can do it. We can do it. Here we go. There we go. I'll make that wider now. I see 000A. Well, if I remember my hexadecimal conversions, A, if I convert to decimal, is 10. This is a VLAN 10 tagged piece of data because I pinged from a VLAN 10 PC here. I'm getting back there. VLAN 10 PC here to VLAN 10 PC here. So that has a VLAN tag in of VLAN 10, or that has a, this frame, Ethernet frame has a VLAN tag in of 10. If I were to ping the other ones, I would see that change to that VLAN tag. But the bottom line here is I deal with this. If I deal with VLANs, it does add that in there. That's an additional piece of data in my Ethernet frame. So there is my Ethernet frame, my Ethernet header fields, and showing you real quickly that little special VLAN tag in there.